Once the spacecraft is in orbit, how do we get from the Earth to the Moon, which is 384,400 kilometers away? Keep watching to know more about Chandrayaan 3's journey to the Moon. The spacecraft is made of a lander module, which contains the lander, rover, and all its payloads, and it also has a propulsion module that has smaller engines called LAMs, the liquid apogee engines, and some chemical thrusters. These components inside the propulsion module all work together in moving the spacecraft around in outer space. The easiest way for this journey is to simply use these engines to propel the spacecraft all the way to the Moon. But scientists soon found out that this is not very practical since fuel or propellant consumption is very high. More fuel adds tremendously to the cost, and in addition, we'll need larger rockets to carry the heavier fuel, and the mission quickly becomes very expensive. A more clever way to journey to the Moon is to employ a common technique called gravity assist or gravity slingshot. Let's use Chandrayaan 3 as an example to understand this. This is the Earth and this is the Moon. The LVM-3 puts the spacecraft in orbit around the Earth. It is the gravity of the Earth that causes the space probe to orbit it. The orbit is not a circle as you would normally imagine, but is sort of an oval or an elliptical orbit. This means that at certain points, the probe is closer to the Earth. When it is closer, it means the influence of the Earth's gravity is more and the space probe is pulled in with more strength and therefore it picks up speed. Later, when it gets to a point in orbit where it is moving farther away from the Earth, it slows down, and this circle continues. One additional detail we will add to our example is the Sun, another central body with a much more massive gravitational pull. Therefore, our spacecraft is in orbit around the Earth, which in turn is in orbit around the Sun. This is also an elliptical orbit. When the spacecraft is moving in the same direction in which the planet is orbiting the Sun, the spacecraft, in addition to falling towards the planet, is also pulled along with the planet which is falling towards the Sun. In other words, the planet is grabbing the spacecraft and slingshotting it away by providing additional velocity. The Earth orbits the Sun at extremely high speeds. So being caught and thrown in this slingshot increases the velocity of the spacecraft tremendously, so much so that you can even slingshot it all the way to the Moon. Remember the LAM and chemical thrusters? They move the spacecraft slightly at very precise calculated moments such that the orbit height is raised gradually in a series of 5 orbital raising maneuvers. Chandrayaan 3's gravity assist slingshot happens in multiple stages to minimize fuel use and make the best use of gravity. In each orbit raising stage, only a slight push is provided by the onboard engines, and the majority of the velocity is provided by the gravity slingshot. Chandrayaan 3 successfully underwent 5 orbital raising maneuvers on the 15th, 17th, 18th, 20th, and 25th of July 2023. The exact moment of orbital raising and the exact push and direction that is to be applied is calculated using a lot of mathematics and physics. Trust me, there is a lot of work that goes on here. The final maneuver at Earth was on the 31st of July 2023 when the trans-lunar injection was carried out, which used the gravitational slingshot to slingshot the spacecraft all the way to the lunar orbit. Chandrayaan 3 took about 5 days to travel to the Moon. It reached the lunar orbit on 5th August 2023. At the Moon, there will be a series of similar orbit maneuvers, but this time to lower its orbit around the Moon. After all the lunar orbit lowering maneuvers, the lander module would separate and begin its descent towards the Moon. Chandrayaan-3 does not have an orbiter like the previous Chandrayaan missions. Therefore, it is only the lander and its payloads that comprise this mission. During landing, the thrusters on board are programmed to precisely calculate and execute this landing, which is planned to be a soft landing, which means we don't just plan to throw something down on the Moon, but to safely land the spacecraft in a soft and controlled manner. We saw what thrust is in one of the previous videos. The thrusters, by generating the right amount of thrust in the right direction, would control the speed and trajectory of the spacecraft and enable it to land on the Moon without sustaining any damage to the craft.